Assalamualaikum and hi, my name is Nurul Imanadira Mikianza. My matric number is 08DEP23F1013.
Nama saya Siti Masara binti Harun. Nombor matrik 08 DEP23S1114.
Assalamualaikum, nama saya Nur Atika Ayuni binti MD Tarmizi. Nombor matrik 08 DEP23F1124.
Assalamualaikum and hello everyone. My name is Amrul Afiq bin Kamrul Zaman. My matrix number is 08DP23F1081.
A stationary point of a function fx is a point where the derivative of fx is equal to 0. These points are called stationary because at this point the function is neither increasing or decreasing. Graphically, this corresponds to points on the graph of fx where the tangent to the curve is a horizontal line. There are two types of stationary point. First is maximum point. At the local maximum, the function reaches a peak and then begins to decrease. The derivative at the local maximum is 0 and the slope of the function changes from positive to negative. And the last one is minimum point. At the local minimum, the function reaches a valley and then starts to increase. The derivative at the local minimum is 0 and the slope of the function changes from negative to positive.
I'm going to explain to you about rate of change. But first, how do we describe rate of change? The rate of change is the speed at which a variable changes over a specific period of time. It is often used when speaking about momentum, and it can generally be expressed as a ratio between a change in one variable relative to a corresponding change in another. Graphically, the ratio is represented by the shape of a line.
So the solution for question 1 is we have to differentiate the y. It will become a 6x minus 6. When the dy over dx is equal to 0, the new equation will be 0 equal 3x squared plus 4x minus 7. Using the algebra method, x equal to 1. Next question is the nature of the curved line. We already get the dy over dx which is equal to 6x minus 6. To get the minimum or maximum point, we have to do the second order differentiation, which is differentiate the dy over dx again, and the second derivation will get 6 only. We don't have to substitute because there is no x at the 6. So d square y over dx square equal to 6. So 6 is greater than 0. So the coordination point will get minimum point. To find the coordination of graph, we have to find axis x and axis y. To find an axis s, y will equal to 0. So 0 equal to 3x squared minus 6x plus 2. Using calculator equation, x1 equal to 1.6 and x2 equal to 0.4. To find axis y, x will equal to 0. Y is equal to 3 times 0 square minus 6 times 0 plus 2. So y will equal to 2.
This is the solution for question number 2. First is step 1. We all know the cylinder volume which VC is equal to x power of 3. Then step 1 is we take from the question which is the dv over ds is 3x squared and the dx over dt is plus 5. We move to step 2. The equation will be dv over dt equal to dv over dx times dx over dt. After substitute the number into equation 3x squared times 5 and then we replace the x into 3, so the answer for the equation is 135 cm power of 3 over second.
The example application of rate of change is economics. In economics, rate of change can be used to describe how variables such as price, demand and supply can change over time. Also, finance. In finance, the rate of change of stock prices or interest rates can be crucial for investment decisions.
In physics, rate of change is used to describe the velocity, acceleration, and other dynamic properties of objects in motion. But in engineering, engineers use rate of change to analyze the speed at which a system changes over time, such as the rate of temperature change in a chemical reaction or the rate of flow in a fluid dynamics problem.
Stationary point on a curve has diverse application in various fields. These points were the first derivative or gradient of a function equals 0 help it determining the local maximum, local minimum, or points of inflection of a function. There are several ways in which stationary points are applied, for example in physics and engineering. In physics, stationary points are used to find equilibrium points in systems, such as the point where a particle's potential energy is at a minimum or maximum, indicating stable or unstable equilibrium. In engineering, they can be used to determine stress point in structure or optimize design for efficiency and safety.
Chemistry. In chemical kinetics, stationary point correspond to transition state which are critical in understanding reaction, mechanism and rate. They also appear in the analysis of molecular structure and energy landscape. Image and signal processing. In image processing, stationary points are used in image detection algorithm to identify abrupt change in pixel value, which can indicate object boundaries or feature. In signal processing, they help in identifying important points in signal or time series data.